Right, question 16. So if you watch the video on question 15, then you would see where this is also coming from. Okay, so we're going to solve this one now. Can you hear me clearly? All right. So how many hydrogen atoms are present in 50 molecules of C4H4S2? Yeah, somebody said this one is 1,4-dithene, but that's the name of that one. I'll give you one wonderful structure of it, by the way. This, this, this. Right, so it has a good structure. Anyway, so that molecule there being a C4H4S2, we're asked how many hydrogen atoms are present in 50 molecules of this. So now let me show you the wrong way to solve this question, okay? So first, we have to program it to forget that moles and molecules are actually different things, okay? So if you're going to forget that, that would mean that you probably see 50 molecules as 50 moles. Then you say, okay, 1 mole of C4H4S2, and then you probably do what we call dissociation, and then you break it and say, oh, it should contain 4 moles of H, you know, and then you say 50 moles of this should then contain about 200 moles of H. And then you say, according to Avogadro, 1 mole of anything should probably have like 6.022 times 10 to the power 23 atoms. And then you would say that 200 moles that you now have of H atoms would then have 200 multiplied by 6.022 times 10 to the power 23 real atoms itself of hydrogen. It almost makes sense, right? Except that because of the initial flaw, which is that moles and molecules are actually different things, this would be wrong. Okay, so let's go back. Okay, all right. So what you're seeing right here, this stuff I'm circling here, this stuff like this is a molecule. That's why I drew it out in the first place. So you see what a molecule of that looks like. Okay, so this is the molecule itself, and this is a diagram of this molecule. This is 1 molecule of 1,4-dithene. So in this 1 molecule, it has 4 carbon atoms, 4 hydrogen atoms, and 2 sulfur atoms. So great. 1 molecule of C4H4S2 contains 4 atoms of H. Okay, so it's good to use the proper terms. That would mean that 50 molecules of this one would contain 50 times 4 divided by 1 atoms of hydrogen, and that just gives you 200 atoms of hydrogen. And this is the correct answer to this question, okay? I'll see you on question 17. If you're not following this page, follow now. Because you probably not see question 17 if you don't follow now. Alright, so I guess I'll see you guys on 17. We're going to 100 by the way. So I'll see you on 17. Bye bye.